A and B are integers or belongs to Z, and for A and B is greater than 0, then prove A plus B, AB plus 1 upon A square B. Prove that A square plus B square upon AB plus 1 is a perfect square. So we A is less than greater than or equal to B, or B is greater than or equal to 1. Let suppose K is equal to A square, one a constant or integer. K is an integer that shows A square plus B square upon AB plus 1, and K is greater than 0. Proof let K is equal to A square plus B square upon AB plus 1. इंटरचेंज के से प्रोडक्ट करेंगे हम इस टर्म को ए प्लस बी ए बी प्लस वन के एज इक्वल टू के इज ग्रेटर देन जीरो इज इक्वल टू वन. One can be written as k a b plus 1 is equal to a square plus b square. A is greater than or equal to 1, b is also equal to or greater than or equal to 1, and k is greater than 0. Assume for contradiction k is not a square, so a is not equal to b. Otherwise k is b square plus 1 is equal to 2b square. We will replace as contradiction a is equal to greater than 1 and b is equal to 1, and a square plus b square is equal to a square is equal to b square. Then we will replace a square plus is equal to b square for a is equal to 1 and b is equal to 1, or greater than k b square plus b. We replace a as b, so 2b square and kb square plus 1 k. From this condition, given condition, we will taking common k is equal to 2b square minus k, 2k b square. K is equal to 2, left hand side root b square only will separate k is equal to b square, uh, 2 minus k, 2b minus k, and b square is common as both have b square minus 2k. Now if we improve our possibility for is a perfect a square plus b square upon a b plus 1 is a perfect square, 3 5 and 4 we will add. Let a is equal to and b of pair is a minimum solution pair, so we cannot find a for satisfaction. We will a square plus b square is equal to kab plus k. Assume kab plus k, left hand side product with kb plus k, and a square plus b square is equal to this. Again we will have a here quadratic equation and formula. Through this we have proved that k plus b square root of a plus a is equal to k b, and a star is equal to b square minus k. From this a square minus kb plus b square minus k, discriminant b square d is equal to b square minus 4ac. If I is a perfect square, then b square minus 4ac is equal to any value not divides. It is equal to a star is equal to kb minus a, and a integer star is belongs to z, any integer. If non-negative possibility a star b square minus k upon b less than b square upon a and less than a square upon a is equal to a, its mean is perfect square is a rational number, and pi or other 0 you can learn through a star and is less than if a 0 is a we select as a integer less than b and b is less than a, then a pair of minimum a b, those non-negative. Only possible scenario, if a is a perfect square, then we have minus 1 whole square is equal to 1, right? This show minus 1 square is a square, so square is a perfect non-negative. B square minus k is less than 0 is impossible. For the sake of the condition, let b square minus k is less than 0, then k minus b square is greater than 0. ये two conditions. So if answer is discriminant is on a quadratic part is less than or equal to 0, then k minus b square is equal to a square plus b square minus b square अपॉन a प्लस b. बोथ साइड पे हम स्क्वायर लेते हैं k एंड माइनस p कर देते हैं. We take this condition and if it is the part of a given part is a square plus b square upon a plus b is less than or greater than 0, then the condition is equal to a square b square minus a cube minus b cube minus b square upon ab plus 1 is equal to a square minus ab cube upon ab plus 1 a into a minus b cube upon a plus b. Given a condition a, so any one digit must divide a plus b whole as a d, but which is only d divides equal to 1. Only one is which divides d is equal to 1. So this part take again. This cannot be judged impossible. A is divided whole divided by ab plus 1 into a as a into a minus b cube. So claim a plus b cannot divide by a minus b square and a is greater than b cube. B is greater than or equal to 1. This implies p cube is greater than or equal to 1 minus p cube less than or equal to minus 1. So a minus p cube less than or equal to a minus p1, a minus 1 less than a plus 1 and less than equal to ab plus 1 must be. So it can divide. So we must say 0 is less than a minus b cube is less than ab plus 1. That is so the assumption k is not perfect square but gives a contradiction. K is a square of any integer. We have assumed here that k in is not a perfect square but k is a square of any integer.